Hi folks, I'm solving Leetcode's top 150 questions and that's all you need for your coding interviews. In this video, we'll be solving 1049 last stone weight 2. This is the extension of the previous Leetcode easy problem which was last stone. We are given this array of integer stones where stone at I is the weight of the ith stone. And we are playing this game of stone where we smash two stones together. And here we are free to choose any of the two stones and smash them together. While smashing, if both are equal, then both the stones are destroyed, and if they are not equal, it will be x minus y. At the end, there are at least one stone left, and we have to return smallest possible weight of the left stone. So two important things from the previous one. There we were only smashing the maximum one, and we didn't have this foundation of returning the smallest possible. We just have to return whatever is left. This makes this problem a pretty tricky. Now let's try to think how we can solve this. A brute force way that you may think about this is probably we will have some sort of backtracking where we smash every element with one another. There are so many edge cases that you may need to handle here. Something like if you smash these two stones, if the total left, if it's 0, then it's fine. But otherwise, you have to manage all of these state of the current stones, and that's what makes it difficult for the brute force approach. A smart way to think about this would be, let's just say you take the sum of all of this element. So the sum of this stone, the total stones is 23. And when we are saying smallest possible weight, what we are saying is we will have to divide this 23 into these two equal piles of stone in such a way that the difference should be equal to or very minimum. So since here it's odd, then the closest possible difference of one pile could be 11 here or 12, because that's what makes this to 23. And now since we have this insight that half of these stones could be sum up to 11, then we can have a better approach to our backtracking. So what I mean by that is, let's suppose our target is 11. Now we have a choice to include this 2 or not include this 2. And again 7, we have a choice to add this 7, which will be 9, or it could be only 2 or 2 itself. But here with this 7 plus 4 is 11. We can say we found this one path which sums up to our total. And this is the logic that we will follow. We will take the total sum, we will have our target sum which is 11, and we will create our backtracking solution. But this backtracking solution is 2 raised to the power n, and we can easily improve it by memoizing our result. So which is nothing but, so two things we are keeping track of. One is index I, and the second thing is the current total. And while we will memorize this, our time complexity will reduce from 2 raised to the power n to, so this I could go up until n. So this will be n times total. And same goes for space complexity as well, because this will be the maximum size of our cache. I hope you found this video helpful. If yes, you can consider subscribing to this channel. And thank you so much for watching.